Uh, Welcome to DPRG's Robot Builders Night for August 27th, 2024. We're going to be talking about robots today, and we're also going to let everybody know that this is recorded. So if you don't want to be recorded, just blank your video and your microphone and just sit and listen. That's fine. Okay, so with that, I'm going to get right started. We have a queue of Ted to start off with. And Ted, you're going to go ahead. It's your floor.
Okay. So I don't have much, but I made a discovery that was I thought was cool. So it might help if you pin me.
Okay.
So I found in my parts bin a steel rod and a carbon fiber tube. And let's see, the steel rod's 8 millimeters outside and the tube's 8 millimeters inside. So I thought both of these were just cheap parts I got on Amazon that I use for building stuff. But I thought, well, let's try sliding them together. And they slide together really smooth. So if I put my thumb over one end, it's like airtight and it'll spring back like that. So I don't know. I just thought it was kind of cool how smooth it slides.
Mm-hmm.
And I'll have to figure out something that slides that uses this.
Well, yeah. The nice thing I can see right off is you can make it a pole, your mass mount. Make your mass mount out of the carbon fiber, and just have a stub of the steel mounted on the robot, so that you just pop it down on top of it. I mean, it's just a thought.
Yeah. Yeah, and I was thinking I'd use this for a mass mount, but the fact that it's hollow, I can run wires through, and if I put the steel under it, then that won't work.
Oh yeah, you'd have to either drill the steel, or I see what you're saying.
But I'm thinking my bumper's working well, so I'm not sure I want to do that. But I was thinking if I redesign my bumper so it could slide back and forth smoothly, and even have some spring action from the air compression on it.
Oh, that's cool.
Because you can. It'll just push in and spring back out.
Mm-hmm. Sort of make it a damper.
Yeah.
Okay. Yeah, that's an interesting idea.
Yeah, I don't know if I want to change that though, because I have something that works. I should probably be working on something else.
If it works.
Yep. Yep. So that'd be for my Robo. What do we call it? Robo Columbus.
Yeah. Okay, that's cool though.
Anyway, that's all I had. I just thought it was kind of cool.
Yeah. Okay. Well, then I'm going to share pictures that Pat sent to Paul and me that he said he wanted to share them at this meeting, even though he couldn't physically be here or even virtually be here. So let me. I'm going to share them. Okay. And we need to go to that one. This one. All right. Okay, are you seeing? I think the name of the robot is Bob. Everybody?
Oh, yeah.
Yep. Yeah. Okay. Notice the steel reinforcements. He's gone all along the outside periphery. It looks like. I don't think this one's got one, but it's down by his wheel for sure. And it looks like he's painted it. And as Paul noted, see that? You know what that is, guys? That's mud. This robot has actually been outdoors and running. It's kind of cool. So anyway, now he has the next picture. This is what he looks like inside. I don't see how it ran with this, though, to be quite honest. He must have used dirty wheels. Oh, wait a minute. he had a robot before Bob. That's how he did it. Okay, so this is the motors are mounted. That's new. And the angle here looks wrong, but he's got another picture that shows that they are lined up. And he's using, it looks like a fairly hefty motor, and he has a better picture of the encoder on the end. So he's using an optical encoder. So these might not be quadrature. These might be only tachometer, but they could be quadrature. I just can't tell from the picture. Yeah, I can't tell. So anyway, some pretty cool pictures from Pat. And I thought he wanted to share, and I think he's well on his way. See, so be afraid, Tommy. Be afraid.
Can you go back to the bevel gear arrangement?
Okay. Is this what you mean, Kareem?
Oh, I see. So the front and rear shafts are split in the middle.
Yes, right here.
Yeah, so I think the bevel gears connect the two wheels.
On each side, yeah.
Yeah.
Mm-hmm. Yeah. And I don't know where he got his parts, but it looks like he got them from they don't look like Amazon parts, just looking at them.
You can get all that stuff on Amazon these days.
You can?
Yeah.
Oh.
That doesn't
and the
mean
bevel
they are,
gears,
yeah.
front and back, if you look at front and back, they're reversed on the opposite side, so the direction's correct.
Yep.
Yeah, see that? They're inside and then they're outside on the other end.
Yep, cool.
Yep. But how are the motors connected?
I think there's going to be a belt or a chain there. Those look like sprockets.
Yeah, this looks like
oh, they're not connected yet.
Yeah, they're not connected. Not there, at least in this picture, they're not.
Yeah.
Yeah, they looks like two sprockets.
Yeah.
Yeah. What I'm a little surprised, I'm just the things. Whenever I've tried to do this, I've always had to have some sort of gear ratio between the motor shaft and the drive shaft, because these are probably 1-to-1 here.
The motor looks like it might be geared though.
Oh, it is. It's got a gearbox in here.
Yeah.
Yeah. So maybe that's how he's achieving it. I mean, look at this motor shaft. That looks like a 1/2 inch or a 12 millimeter. That looks like a 12 millimeter shaft, or maybe even bigger. I'm assuming, I don't know what he's using here, but that actually looks bigger from this picture.
He had talked about you.
Hello?
I think we lost him. I would have used a belt, but.
Well, I don't know. I mean, Kareem can probably wax poetically about the differences between belts and chains. You know, it's not clear here just looking at it. His motor would have to be able to move upward, I think, to have some effective tensioning.
Yeah.
And
you don't need nearly as much tension on a chain.
All right.
Yeah.
I'm pretty sure that he's probably already sized it for the links that he's got.
Mm-hmm. Yeah. Yeah.
It looks like the motor is mounted. If you look behind the wires, that looks like a L bracket that may be slotted.
Yeah, that's what I was thinking.
So he has a little bit of vertical movement there.
Yeah. Yeah. Or if he hasn't, he could add it easily.
Yeah.
Yeah.
Uh-huh.
Although, I hope it's got an L bracket on the bottom as well, because it might want to pull away under reverse, or depending on which direction he's going.
Yeah. Well, let's see if we can see anything here. Well, can't tell there.
No.
There's something here.
Yeah.
But, you know, there's something under, that's the backside of the motor. Here's the bracket.
I actually don't see. Wait a second. Oh, that's the other side.
Those are really fine teeth on the encoder. Wow.
Yeah. Well, you can get optical encoders that are really, I mean, that's what usually all of, you know, like inkjets and all those type printers, they always use optical encoders. Yeah. But, oh, you know, I don't know. You know, and you can get optical encoders that are quadrature too. So, I mean, it's just, I just don't know what he's got there. I can't see.
Yeah. Does he have one or two sensors? Can't really tell.
Yeah, they could be in the same plastic block.
Yeah.
You only need a 90-degree shift in the spacing.
It does look like there's 4 wires coming out of that. At least.
Yeah. Yeah, it does, doesn't it?
Yeah.
Yeah, I think that he must have quadrature from that.
Yeah.
Yeah. Hey, Kareem, since you're over here and we're talking belts and stuff, is for an outdoor robot, which one do you think would be the better, a belt or a chain?
Well, this is entirely protected inside of the chassis.
Right now, I'm
So-
just talking about outdoor robots in general.
In general, I'd probably go with chain and something this size.
Mhm.
Chain is always going to be easier. I mean, we do mostly belts these days, just because they're a little bit more efficient. They're a hell of a lot quieter. They're clean, and you know, and if you get the tooth right for the tooth size right and tension right for the torque you need, it's hard to beat them.
Mhm.
But you got so much more wiggle room with chain, like so much more room for sloppiness.
Mhm. Yeah, yeah.
Really, it's like you got to make sure that you got a really tight belt design before you go in that direction. They're also harder to manage, right? With the like if you need to replace them or you know put them in place, and managing the tension on them. So you got to have solid reasons to go from chain to belt, I'd
Mhm.
say.
Okay, well, that's good to know. Since I've got belts on my little prototype, what you're telling me is I should have gone with chain. So,
The lower the smaller your robot is,
Yeah.
the more easier it is to do belt,
yeah,
right? You go to high torque on and high loads. I mean, you see motorcycles belts, right? And you see, trucks and alternators and all sorts of stuff. You can make a belt work in most situations, but it's easier to use chain generally.
yeah. Okay, well, that's a good piece of insight. All right, so I think that handles Pat. I'm going to stop sharing, and we'll go to the next person on the list is Tom, who's going to share some learning that he did.
Sure. Let's find it here. Should be somewhere. Come on, where are you? There, that's it. First, make sure you can see that. Just a little bit of a background story. Back in February, back in February, the city I live in, their IT systems suffered a massive data attack, which shut virtually everything down in the city that was IT based or telecommunications based, everything except policing, which is on a separate system. So no public transit, no public library, no IT systems, no pay, no nothing for weeks and weeks. They've slowly been rebuilding their IT systems. They're at about the 60% point now, about 6 months later. The public library systems came back online 2 weeks ago, and that was kind of cool because that meant I could search the library system again in order to have a look at some background material for MicroPython and Python, having decided that I need to learn about that and want to move in that direction on the 32-bit processors I'm now using. So I got a whole bunch of Python and robotics-based books and MicroPython books from the library, and I'm working my way through them. This is the first three, which I thought I'd describe in terms of what may be of any value to some of the rest of you looking at Python. The first one is a little heavy. It's these are mostly brand new. 2024, which is a second revision. The second one from 2022 by Mike Riley. Some of you may have heard of Mike Riley. He's a fairly prolific hobby technology writer. And the bottom one is 2024 as well. The first one wasn't quite what I expected. It's much heavier than I thought. There's an enormous amount of math in this textbook. Although it's moderately well presented, it wasn't the kind of stuff I was looking for. I was looking for what was in the fifth part of the book, back in the ending 4 or 5 chapters, where he begins to talk about running Python on Picos and on Arduinos, which he actually doesn't do. It turns out they just became peripheral controllers that he was running from much larger systems. So all of this stuff runs on really large systems running Python. He begins with relatively simple simulations, recursions, demonstrates some turtle graphics things, which he'll use later. Starts to show some of the many libraries available from a data management and a processing point of view. Things like, and I'm going to read a few of these, the Karplus strong algorithm, of course, which I've never heard of, and I'm sure everybody here has heard of it before.
Oh yeah, that one. I remember that one.
If you're heavily into music,
I think I learned that one first grade, something like that.
it's used to simulate the sound of a plucked string when you do musical simulations. Never heard of it. He gets into more advanced simulation work in section 5, where he begins to start to look at larger data environments as well for the simulation systems he's building. Chapter 8, he gets into autostereograms, which basically are 3-dimensional depth maps, transformations, mapping. Then he starts to talk about buffering, because by this time he's building massive multi-dimensional data structures. Not something I want to go to from a robot point of view. Earlier, he introduced the 2-dimensional game of life, which I'm sure everybody knows about. Yeah. In chapter 10, he takes the running game of life and he maps it to the surface of a 3-dimensional torus while it's running, of course, which lets him talk about lighting, points of view, mapping, viewpoints, manipulation of this 3-dimensional dynamic data structure that he's now built. I put a picture of it up there. That doesn't happen to be his, but it turns out that lots of people have implemented this and have YouTube videos that show it running. It's an astonishing thing to see.
Kind of funny because asteroids is also a torus. It's just not painted onto a 3D surface and then re-rendered back onto 2D. Well, I skipped a couple steps.
I'm skimming through these chapters because I'm at the point now where I can't read this stuff anymore. But my jaw just drops at what this guy is doing, and he's trying to explain it step by step. So if you're into this kind of stuff, then you may in fact want to pick up this book. He does get into some machine learning in the last chapter. The machine learning is using the Google Colab system for the training, and he's attempting to do some speech recognition. And that was about it. It was an education. The book went back to the library fairly quickly. It's not something I need to keep on my bookshelf. But if you like math, especially really, really complicated math in Python, then it might be your cup of tea. The second one was a lot more interesting, but still not quite what I had in mind. This gentleman begins by building a very, very simple robot. 2 wheels using, let's see, what did he build here? A Raspberry Pi 4, with a bunch of peripherals he plugs in. I'm sorry, not a robot. This guy doesn't do robots. He's doing home control. So a Raspberry Pi 4 and a bunch of other things that he talks about that he uses as basically hats on the Raspberry Pi in order to get some sensors working and to provide some interfaces either through the web, or you'll see at the end of near the top there under the picture, an IR transceiver as well that he interfaces. And a PiCam, because he's going to do some face recognition. Talks about setting up software, and this is where I learned the most from this particular book, because he talked about setting up a Python environment running under Linux on the Raspberry Pi that I had not run across before. Some of this stuff is pretty obvious: the operating system, SSH, Python itself, and pip. He runs a local Git in order to do version control on his software, and I thought that was a really good idea. And then he says you really need to put rclone, and you need to build a Python virtual environment in order to work. This is kind of like Docker, I think, Paul. Build a Python virtual environment and run supervisor in it. I had not heard of those, but he makes enough of a case in the chapter where he discusses this that I think I probably should look some more into this for development purposes in my MicroPython stuff as it gets more complex. I don't know. We'll see where it goes.
I would say this: the virtual environment, that's almost a must if you're going to use Python on a Raspberry Pi to keep you from getting into version hell, because everything in Python changes every 15 days.
I'm learning that, yes.
So if you do it in an environment, a virtual environment, and you get squirreled, you can just blow the environment away and start over without having to completely.
He makes exactly that point, Doug.
Yeah.
If you're not familiar with this stuff, then this particular author's chapters in setting this environment up, I found to be very, very good. And I may go back and look at them again if I get stuck doing this. I'm sure that there's lots of tutorials on it, but I have not run across them before. And now I'm going to start looking for them. Because this is a home control system, he does get into web interfaces fairly quickly and fairly extensively. And he says at that point, use a web framework. And his choice in this application was something called the Flask web environment. So he talks a little bit about Flask. I know there are others, but he seems to like this one. He also makes a pitch for which kind of editor you should do your Python development work in. As far as the projects go, I have a mindset around what home control would be, which tends to be more gadget oriented. A lot of the work he does in his projects section isn't gadget oriented, it's information oriented. So you can see things like his first project, something called a Twitch timer. He likes to watch or listen to Twitch streams in order to educate himself on various topics. But he says he tends to start them late at night, falls asleep, and the Twitch stream runs all night. So he wanted to find a way to stop that from happening. So he built a tool as part of his home control system to do that. The second one's fairly simple. Attach a water leak sensor, figure out when your basement's freezing or your freezer is melting, and then send yourself an email. It was a nice, simple, interesting project. He builds on that by, let me make sure this doesn't go. He builds on that by adding and demonstrating an interface to the Philips Hue remote control system, a Wi-Fi based system for lighting and for fans, and then adds a temperature sensor so he has a reason for turning the fan on and off remotely. Again, nice, simple stuff, and I enjoyed it, but it's not something I would waste a computer on. Then he gets into voice recognition, and this is where it gets a little bit more complex, but there's still a lot more data analysis going on. He takes a look at some RSS feeds, identifies several of them in this project, but realizes that you have to do a lot of data capture and analysis of what is coming in on the stream. And he introduces a library called Beautiful Soup, which apparently does an amazingly good job at processing and parsing HTML code. I don't know how it works, but if I ever had to do this, I'd certainly go back and look at that again. At this point, he's capturing stuff, throwing it into a database, so he's now got SQLite running on his home control server, wants to do some audio I/O, and the whole thing gets saved for later. So he can then go back to his home control center and see what he saved and listen to it offline. At the next point, he gets into wanting to wake up devices on his local area network using his home control system. He wants to do it using voice control. So he now ties his home control system into the various voice recognition systems. He uses Google Home, but acknowledges that there are others which work just as well. He ties information from Google Home into the if this then that server. He uses outputs from that server to send information to the push bullet server, which I'd never heard of before. The push bullet server then sends stuff back to his Raspberry Pi, and he then uses his Raspberry Pi to issue wake on LAN commands over his local area network. It sounded incredibly complicated, but he's trying to build some knowledge of how this class of tool set works in an infrastructure. He does it fairly well. The next chapter simply adds the output of infrared control information so that you're not restricted to being able to remotely control just things sitting on your local network, but you can also control stuff that's hooked up or that's controllable by infrared remote controls. If you like to do that kind of thing, he walks through it very, very carefully and has a number of module tests and step points in the exercise where you can make sure you're actually building it correctly. So if you wanted to do this, this is a pretty effective way to do this kind of stuff. Again, the last couple of items are fairly straightforward. He adds a camera interface using a Pi camera, does some motion detection, and when he detects motion, he sends himself an email. Good basic grounding for some of the things you might want to do with a home control system. Not what I normally thought of as home control systems from what I've read, but could well be. And finally, the last one, which I found a little bit more interesting. This gentleman builds himself a very basic robot, a couple of TT motors, a Raspberry Pi 4, and a top hat that has something called a Cricket interface, which Adafruit makes, which he uses to provide the H bridges and some sensors and some servo controls. And then he walks through the exercise of how to control this thing, initially remotely with very simple stuff, all in Python, incidentally. Shows how to write custom REPL shells to control the robot, which I didn't know you could do, but that's a really neat idea, and he makes it look very simple. Then he moves into web control. His choice of a web framework is Tornado. I mentioned the previous guy's choice was something called Flask. This guy chose Tornado. He then shows you how you can begin to develop your own client services under Tornado. At that point, he starts to build web applications that run on browsers or on smartphones that run through this web interface. What's next here that's worth looking at? He begins to add a camera. And when he adds the camera to his robot, then he begins to introduce OpenCV. I thought that was pretty cool. And he goes step by step how to not only access the camera, see the videos and the frame grabs, but also do video overlays. And because his camera is sitting on a 2-servo positioning device, then he shows you how to do servo control in order to track stuff. What do you want to track? Well, faces. Shows you how to use the libraries that are part of OpenCV to identify faces using something called HAR classifiers.
Yep.
Those of you that have done this will recognize this. I don't recognize it.
Yeah.
And then he works very hard to get the performance on a Raspberry Pi 4 doing face recognition up to real-time performance levels. His goal is better than 30 frames per second face recognition on videos in real time. He achieves 75. I'm really impressed with that, especially after listening to the things Bob Cook had to do to get his stuff running. This guy seems to know what he's talking about. Once he can do faces, he said, well, let's go look for QR codes dynamically, identify them and interpret them and respond to them in various ways as the robot is moving. His examples of how to do that are a little bit trivial. He invents this snack pushing robot idea, but it's still fascinating stuff. I found this book a lot more interesting than the previous one. especially since eventually I intend to do web control of robots and don't have a clue how to do it yet. And he walks you through it very carefully. Also, the camera and face recognition stuff looks good. He showed a picture of his robot, which I grabbed off of the publisher's website. The other thing he does is every time he develops a new concept in a new chapter, he begins by providing some diagrammatic references to both the software and the hardware he intends to introduce as part of an overall architectural frame that he developed early in the book. I showed you, there's a picture of one of those hardware frameworks where he color codes the things he's going to use in that particular chapter, the things he'll introduce. I thought that was a really, really nice way to show how all this stuff fits together. Start out in the beginning with a framework you don't understand and then show how it develops over time. This guy's pretty good. I was impressed.
Okay.
I'd like to just be careful about distinguishing between face detection and face recognition.
Okay.
Our classifiers are usually face detection,
Okay.
which is different from identifying a particular individual. It's just
Okay.
something that
Good
looks like
point.
a
Very good
face.
point. I was certainly impressed by the fact that he could identify faces at all and could do it very, very rapidly.
Yeah.
Whether he could differentiate between faces, I don't know. He doesn't get into that. Okay.
Yeah. Well, hey, that's great, Tom. I'm glad you did that, so I don't have to.
Yep.
I'm thinking that that last book, what was the name of it?
Oops, sorry. Let me just put it back up.
Something like build your own robot or something like that.
Yeah, I mean,
Yeah, I'm gonna stick this into here. If I can find it. Where is it? Okay. There it is in the chat. That's
okay.
the last one.
Okay. Yeah, because I'm just thinking that that last book sounded very interesting. That might be something. I'll
Yeah.
put it on the list, maybe down there, numbers somewhere between 247 and 263, somewhere in there. And if I ever get down there,
Yep.
cool. So,
I've made a little progress on my own robot. I had been struggling to use async IO in MicroPython on the ESP32 I'm using. It took me several days to finally discover my really dumb mistake I was making. And now I'm very, very happy with async IO. I have 3 different time-based loops running in the testing work that I'm doing as I develop functions for this robot. And it's easy and it's effective and it does everything it's supposed to do, finally, after I fixed my mistake. I don't know if somebody else here had tried to use it and gotten lost in it. But in any case, it's working really well now.
yeah. Hey, Tom?
Yeah.
If your robot's right there, just to kind of help everybody sync up, if you could pick it up and just show it real quick.
Sure.
So we all get our mindset on what we're talking about here.
Yeah, I think he has a big one. He has to carry it all the way over.
You should, Ken, if you want to see a better picture, I'll just hold it up.
Oh, yeah.
One
Yeah.
tenth
Oh,
scale.
yeah. Now you see it.
Ackerman steering, rear-wheel drive.
Yeah.
I've actually got it partially disassembled as I add some more interfaces to it. I have a sitting in the middle here is a radio controlled.
Bring it up higher, and
There,
tilt it towards us.
There, how's that? I don't want stuff to fall
Not,
off.
we went back down, up higher.
Yeah.
There you go.
There you go.
There's a radio controlled receiver here, and I want to read the receiver's channel pulse widths, but I don't want to do them separately on GPIO pins. So today I was building a PPM encoder so that I can just read a single PPM stream in the ESP32. And there's existing MicroPython code to do that. Started actually quite a while ago by John Hyland's brother, Dave, and then continued by a number of other people. So the software is pretty simple, pretty straightforward. Just interrupt-driven timers, that's all it is. And I have the H bridges running under computer control for the drive motors. I can control servos. There's 2 RC servos on this thing. I can control those quite easily. I have displays and push buttons running for interfaces. And I decided I needed a little bit of odometry because this is a toy. It doesn't come with odometry.
Mm-hmm.
So I've added a bunch of magnets inside the hub of one of the wheels, and I've placed a Hall effect detector to pick them up. And that's working very, very well. So I'll have some basic odometry on the drive wheels as well.
Yeah, that's probably all you need.
And a bunch more sensors once I get to that point. But we'll see.
Yeah.
It's unfortunate my radio control receiver doesn't have a PPM output on it, but I disassembled it enough to be able to probe it with my scope and determine it does not, unfortunately. Many of them do, but that one's a little bit too old or a little bit too cheap.
Yeah. Well, I don't know. I think the move is away from PPM.
Oh yeah, PPM is really old technology.
Yeah,
But you know what? It's easy.
Yeah.
The PPM encoder is simply basically it's a diode OR gate and a little bit of extra stuff. So it's really simple. I don't know whether you wanted to look at our course layout now or a little bit later or what.
Well, is anybody, we're going into open mic here. How everybody's been really quiet. I haven't heard anything from Ray. Ray, you there?
I'm here.
You got anything you want to add because you came a little later?
No.
Okay. Well, okay. I tell you what, Tom, since I don't think anybody else has got anything else, let's see this course that's going on for Robo Columbus in Canada. Let's see what it is.
We'll see how well this presentation method works. I'm going to open a window.
Okay.
This one. And this window is a private map, a Google map that I built. And on the map, can you see that?
Yeah. Hey, wait a minute. Guys, I learned something that I didn't know how to do before. If you hit the 3 stars and go up to change layout and you hit spotlight, I think it will give you the whole screen. Well, I thought it would. Why is that not? I thought spotlight would
Well, do you have something pinned?
that's what it is. Thank you. Okay, yeah, spotlight makes the picture as big as it can be on your computer. All right, so I see some pictures and I see little pictures, so I assume those are pictures.
Yeah, so I've embedded icons, numbered icons in here, which are linked to a series of panoramic views that I took at ground level of the park. Because
Okay.
when you look at the satellite views or even the street view, there's a street view along this highway, but the highway is elevated and the street views are old and the satellite views are even older based on what you see in the satellite view versus what you see at ground level. Now, I don't know whether I can activate these and you'll see them. Let's try. There. I don't know how useful that is. Let's see if I go here.
Can you make them bigger?
Well, that's what I'm working on. Let's go over here and make them bigger. I can when I normally run it, but today it isn't going to. Normally, when I click on this, the medium-sized picture, I get a bigger one. It's not doing that, or if it is, we can't see it. That's one of the reasons why in the email, if you've seen it, Doug, for the few of you I was interested in getting feedback from, I also sent a link to the Google album where the panoramic views are located.
Okay.
They're all high definition pictures, and even when this thing goes full screen, it's still not high def, and it's not going full screen, unfortunately. So,
okay,
I can make it go away. And basically, let's see which ones are useful here.
so kind of just looking at
I'm gonna zoom here.
where do you plan? Just
Right. Yes. The agreement I have with the park people is that we will not do the robotic stuff down here where the pavilion and the parking lot is.
Okay.
It's nice, flat. It's well-kept lawns without much else there. So it's not that interesting anyway. What I want to do is I want to go up here in this area, the different colored green stuff, which is moving down towards the bottom of the screen, is naturalized park area. Okay? It's not maintained particularly well.
Is it cut?
And let's see if this picture helps. Does that help a little bit? Yeah. Can you see that or not?
That might be a little tough for you. That would be a bigger challenge than I think what we do up at Steve's. Because he at least cuts the grass.
Yeah, I should probably open up the full-size views of this. What the picture is intended to show but doesn't do well is that the parks people have mowed pathways that they maintain through the naturalized area.
Right.
So, in fact, you can see it a little bit here. The reality is this is not the current arrangement of those paths. For instance, you can see a big rectangular area in the center here.
Yeah.
That's not there.
Okay.
However, some of the other paths are. For instance, this path is there. This path is there. And this path. And a few others, which I show in my panoramic views. There's also an elevation change on the order of perhaps 10 or 15 feet over about 100 yards or 150 yards in this area. So it's slowly moving uphill.
Now, if you go up to the big field up there above, go up higher. Okay, is that mowed?
Yes, it is. It's cut just like your front lawn.
Okay.
Well, a little rougher maybe. I don't know what your front lawn looks like, but
Yeah. Well, I mean, that would definitely be suitable for your home cone to first cone.
exactly. That's what I would do as well. So between the maps and the actual ground zero pictures I took, what I was hoping to get was input as to what would constitute reasonable paths and paths that would satisfy the distance and layout requirements of the competition itself.
Yeah.
You can use the Google dimensioning tool on a standard Google map. You can't do it on private maps, but you can do it on a standard Google map and you can get reasonably accurate dimensioning information.
Yeah, that's usually what I use. If you go over to that picture, there's one picture that might be of interest. Keep going to the left. I mean, right. Go to the right there. Yeah, that guy.
This picture, you can see if you can read the text, I was facing northwest, and north is towards the top of the map, west is towards the left, towards the highway on the left. That's west. So I was facing northwest, and that's the center point of the panoramic picture. And I'm standing just inside the uncut area at the first intersection of 3 of the mown pathways, looking back towards the pavilion, which is north.
So if you look at that, okay, close that picture. If you look at, you see next to the picture, there's a tree, and then over a little further on the right next to the picture, there's another tree. No, go down. That tree and that other tree. Looking at it, this area appears to be mowed.
It is mowed with pathways. It's not completely mowed. The pathways are the width of a farm tractor towed lawn cutting arrangement. Okay, if you know what I mean, people who use those for cutting large areas of lawns. So a small farm tractor towing a collection of several lawnmowers behind it. 10 feet wide, maybe.
Yeah, because what I would see is take your cursor and go up. Oh, wait a minute. Okay, Yeah, go to the left. To the left. Down to the end of the tree line.
Left towards the highway?
Yeah, right there. In that area somewhere would be to start. And then
Yes.
the other, if you go 100 yards to the right,
Yep.
somewhere up there, still in the field,
Yep.
you would be somewhere where you could put your a second cone.
Yep. I agree.
And your third cone would probably be
Down here somewhere.
somewhere wherever 100 yards is, you know,
Yeah.
in that area. That would be one potential way to do it. Now, the other thing you could do is use those trees up there, the tree line or next to the road.
There's a lot of stuff here that constitutes reasonable obstacles.
Yeah.
It's hard to tell from this picture, but the uncut areas in this naturalized space
Mhm.
right now contain grass that's potentially 1 or 2 or 3 feet high.
Mhm.
Now, it won't look like that at the end of October because the grass will all have died, but they won't have removed it. It'll just be lying there on the ground.
Yeah, I guess the real question is it something that you could reasonably detect with obstacle avoidance?
I'm hoping so, yes. Certainly the trees will be good obstacles, and the trees and bushes
Yeah.
are reasonable, and they'll still be there.
Yeah. Okay, well, it looks like you got a good site, and you say you have permission from the park folk?
Yep, I sweet talked them, and finally they agreed that this sounded like exactly what they want people to use the park for, as long as it's not very many people, and as long as we don't break any of the other rules. You know, we have a million rules for city parks, of course, and
Yeah.
as long as we never interfere with anyone else's use of the park.
Yeah, so
And
for
that
example,
shouldn't
the robots can't fish in the pond, right?
She says, do the wheels tear up the grass? I said, no, they don't do that. She
Yeah.
says, how fast do they go? I said, well, maybe 5 miles an hour.
Yeah. Okay, now you're gonna see somebody's robot's gonna be running on, you know, like 15 miles, but that's never mind.
Challenge accepted.
Well,
Say
that
that
sounds
again?
great. It really sounds like you made progress.
Well, I
I'm
intend that.
expecting Robo Columbus North
Yeah.
to be a go.
When my robot's ready to take outside, then I will bring it here ahead of time, partly so I can get some trials in, but also I want to contact the park manager again that I'm dealing with and say, come and look at my robot. I want you to feel comfortable with this.
No, I wouldn't bother with that.
Well, I will, because I don't want them to be surprised.
Yeah, I'm just saying is if they said it was good, I'd go. But okay, you know.
Anyway, I think
you know your park people better than I do.
She didn't get too excited about, I mean, normally with groups, you got to get a permit, you got to pay fees, you got to do this, you got to do that, you got to buy insurance. She says, what, 3 people? I said, yeah. Okay, that should be fine.
Okay, that sounds great. Okay, well that's neat. All right, I guess that you can stop sharing now, and we can go to let's see here. I need to switch back. Change layout tiled. Okay, cool. Let's see. Has anybody else got anything else they want to talk about? Boy, it's kind of quiet today. Well, you know what happens when nobody says anything? We all go bye. So I'm going to say that we had a good meeting. Let's cut it off and not waste anybody's time, because they got to go work on their robots tonight now that they got a new book to read, and they've seen a couple of robots. So let's go with that. All right, so I'm going to stop recording. So if you want to say something after the recording, let me know. Okay, we stopped the recording and we've stopped the transcribing. And let's see, do we have chat?
Can you hear me?
When it transcribes, does it also capture the chat?
Can you hear me?
Yes, I can, kind of. Yeah. Now I'm not hearing you.
He's supposed to soon. Yes, it does capture the chat. Can you hear that?
I'm sorry.
Does capture the chat.
Okay, cool. That's
Um,
good.
Yeah, and boy, that was Doug. I've got a kind of a question for you, just out of curiosity. So I'm the oops, editing the video from Saturday's monthly meeting, getting rid of dead space and technical issues and whatnot, and chapterizing it in quite a lot of detail. Can you hear me okay? Up in my audio is.
I'm kind of getting, so you're working on the video is what I gathered out of that.
Yeah. But I'm curious, how was the meeting in terms of size? What was there a lot of people there? Was it like
We
the
had
usual or
total of, let's see, 2, 4, 6, 8, 10 or 12 people there.
okay? And were there people that we don't usually see, or was it the
Yes, there
usual?
were. There were some
Oh.
people from the makerspace.
Oh, great.
In fact, we had one person who really got it. Do you know what I mean? They really, I think he went from 0 to 70%, and he was the gentleman who was in the gentleman who did the PCB meeting a while back. I can't think of his name right this moment.
Oh, yeah. Brady.
Yeah, okay. So Brady's friend, the one who created the jig for headers. Do you remember that?
Oh, yeah. That was.
He was
it
there.
wasn't
He was there,
Paul-
and he
was it
also,
Paul
like I said,
Urbana?
seemed to get an awful lot. He was the one who followed along with the making the parts and everything the most.
I think
So
that was Paul Urbanus, right?
I don't know.
Yeah, that's who it was.
Yeah.
Yeah.
So,
Yeah, he's a DPRG member, has been for a long time.
mhm.
Oh,
So
cool.
he,
That's great to hear.
yeah, and Harold was there, and Ray was there, Kareem was there. I believe Kareem was there. You were there, weren't you, Kareem?
In spirit.
No, you
No,
weren't.
he wasn't there.
Okay. All right. There was. All I'm saying is there were a lot of people who were normal people. John and others, but there were people there that I hadn't seen before. And there's a gentleman, I know you know who I'm talking about. He's tall, he's real quiet, and he showed up for about 3 or 4 of these meetings.
Yeah,
He doesn't come on to our Robot Builders Night Virtual, but he shows up at the meetings, on the monthly meetings, and he was there. He's active in DMS too, but I don't know if he's a member or not.
yeah. I'll say his name's like
Oh, that's
Kyle,
great.
maybe. Kyle or Zach.
Is
Yeah.
he kind of tall and
Really tall. Yeah.
and quiet? Yeah. That's probably who it is. So it was a nice crowd. I mean, and we ate 3 pizzas. So, and one of them was white. I'll tell you what, pizza wasn't made to be white.
That wasn't the one I ordered last time, that's for sure.
So anyway, so next one I believe it's going to be JTAG with Scott. Yeah, and my understanding is that
Mike Williamson.
Mike
Mike
is going to do a secondary simplest ROS implementation that you can have. He's going to go through it. So that's going to be kind of interesting too.
Yeah,
Yeah.
he bought that on Saturday and showed it to me, and yeah, it looks really good. It's a really good setup.
Yeah. So we'll see how that goes. And yeah.
I'll be able to be there, so I'll look forward to seeing you guys.
Yep. Yeah. And this next time I'm hoping to, I think we've pretty well tapped out Harold's boxes of stuff he wanted to get rid of. But, I've got some stuff that I want to get rid of, and I don't know if it'll go, but I'm thinking of doing it. And I'm also anyway, I might have some things I might want to actually see if people want to buy. So when I'm talking about, I've got an old 3D printer and stuff like that. Let's see. I think I've got a Creality in the box. So let's see. I'm not.
Yeah, you should advertise that.
I run out of places.
Advertise that on this list before the meeting.
Yeah. So anyway, we'll see how it goes. That's it. I'm gonna hang it up, guys. So.
All right. Thanks, Doug.
All right.
Thank you.
Okay. Bye bye.
That was a very nice marketing video, incidentally. I was very impressed.
Wasn't it?
Yes.
Wasn't it though?
Okay. All right. Bye bye.
Bye.
Bye.